The process of wet granulation is widely used in the production of solid dosage formulations in the pharmaceutical industry. Because of the diverse nature of pharmaceutical materials, granulation is often employed as an intermediate process to enhance flow and compaction properties and improve the final product performance. Since the properties of a wet granule have a critical effect on the resultant dry granule, tablet, extrudate or spheroid, a quantitative measurement of the rheological properties or consistency of a wet granule is valuable. The consistency of the wet mass is a function of the distribution of the granulating liquid in the available pores and voids between the powder particles and has been shown to be related to the end product properties. Mixer torque rheometry offers a means of characterizing the rheological behavior of wet granulations by correlating the consistency with a numerical value. Mixer torque rheometry is widely used in the pharmaceutical industry as the structure of the wet granulation is not compromised. Consequently, the technique gives highly representative and indicative measurements. The Mixer Torque Rheometer MTR comprises a mixing bowl containing two horizontal contra-rotating mixing blades. The secondary blade rotates at twice the speed of the primary blade. Since the bowl pivots about the primary drive shaft, the action of mixing a wet powder mass generates a torque, which is detected via a torque arm by a load cell. The torque generated is directly related to the consistency of the wet powder mass in the bowl. The result most usually reported is the mean line torque. The mean line torque is the arithmetic mean of all data points collected during a logging period. MTR may be applied in the research, formulation development, process development and process control areas of pharmaceutical granulation. Investigations have been carried out into the granulation process. Many materials studied using the Mixer Torque Rheometer have exhibited an increase in measured torque values with increasing binder content, rising to a maximum, thereafter decreasing as a slurry is produced. This behavior is consistent with the differing states of liquid saturation in an assembly of particles. The MTR also enables binder-substrate interactions to be analyzed. For example, it's been shown that substituting different polymer binders has an effect on the rheological behavior of a granulation. These observed differences may be correlated with other binder-substrate interaction phenomena to assist in the binder selection process. The MTR may be employed as a formulation development tool, offering savings in both time and resource usage. Mixing time is a critical parameter in the granulation process, particularly when processing with high shear granulators. The MTR may be used to examine the role of various material parameters in order to assess their influence on the required granulation endpoint. The relative proportion of liquid binder added to the dry powder may also be varied in order to obtain the strongest granule. Changes in liquid binder content will affect the mixing time required to distribute the binder effectively. The MTR offers the ability to observe the subtle differences in the rheological behavior of wet granulation caused by varying the binder solution concentration, type, and the binder-powder ratio. The MTR is ideally suited for monitoring the consistency of wet masses produced with production-scale mixers because it uses such small sample sizes. The consistency measurement may be used to indicate the equivalence of rheological properties of mixes, even between granulators of different size or design. Ultimately, the consistency measurement may be regarded as a pseudo-viscosity term, which can form part of a predictive scale-up strategy. This video gives a brief overview of the capabilities and applications of the Mixer Torque Rheometer. For further information, please contact our local agent.